In this video, we're going to take a look and see what the graph of a quadratic function looks like. So the graph of a quadratic function, that's a function of the form. The equations we looked at earlier were of the form ax squared plus bx plus c is equal to 0. So if this is a quadratic function, this is going to be set equal to y or set equal to f of x. So our function is going to be in terms of x and y. So I'll write it down. F of x equals ax squared plus bx plus c. So now we're looking at all of the values of x and y that make the equation true. Previously, we set y equal to 0 and found the places where if y is 0, what is x? So what does the graph of this look like? So every parabola looks like, or every quadratic looks like a parabola. What does that mean? It either curves up or it curves down. Our parabola curves up if a is a positive number. So a has to be greater than 0. I put an equal to, but a can't equal 0. So when a is greater than 0, when you have a positive value, our parabola opens up. If a is less than 0, so if the number with x squared is a negative number, our parabola will open down. So the defining feature of each of these graphs, notice they each have a turning point. In this case, that turning point is called a minimum because the function decreases until it gets to that y value and then increases. This here is a maximum value. In either case, it's called the vertex. So the vertex is the either the maximum or minimum value of your parabola. Okay. Then, just like any other graph, we also have x and y intercepts, and I think I'll get into that on the next graph. The other item, notice, this right-hand side, if I drew it correctly, should look like the left-hand side. So if we were to draw a vertical line straight through the vertex, the left side and the right side are mirror images of each other. That line is x equals some value, and it's called the axis of symmetry. So that's what the shape looks like. So how do we graph these? In a previous section, we graphed by plotting points, but wouldn't it be nice if we could find that maximum or that minimum value, if we could find the vertex, and then it would also be nice if we could find the intercepts. So intercepts, remember, x-intercept and y-intercept. When we graph lines, we let y equals 0 to get the x-intercept and x equals 0 to get the y-intercept. So we're going to do the same thing with the parabola, except we have, in the graphing lines, we had a slope, and now in graphing a parabola, we want to find a vertex. But it's a little bit more complicated than taking a look and just finding, putting it in a format and then just looking at a value. So let's see how we do that. So we're going to graph the function f of x equals x squared plus 2x minus 3. I've plotted some points. X equals -4 to 2, substituted the y value or the x value in to get the y value, but this is a lot of work. Okay, so we want to be able to graph this a little bit quicker. A couple of the values here, just a reminder, this point down here at the minimum is called the vertex. So we're going to be able to find that point. Then the y-intercept is the place where it crosses the y-axis. So that's the y-intercept. The x-intercepts are the places where our graphs cross the x-axis. So this one has 2 x-intercepts. And if we could find these 3 points, or 4 points, the vertex, the y-intercept, and x-intercepts, then this point on the other side of the y-intercept, we know that it's symmetric. So once we have the y-intercept, we also have another point just because of symmetry. And if we have those points, the key points, then we can sketch a graph best we can. So finding a vertex is actually a formula. And this formula is in terms of a, b, and c. So in our parabola, our equation f of x equals x squared plus 2x minus 3, a is equal to 1, b is equal to negative 2, c is equal to negative 3. Oops, b is equal to positive 2. So where this comes from is completing the square on the parabola. It's that completing the square is not a part of this class. We're just going to use the result of that. So to find the x coordinate of the vertex, it's a formula negative b over 2a. So all I need to know is what b and a are, and I've got the vertex. So in this case, the vertex is negative b, which would be negative 2, over 2a, 2 times 1, gives me negative 2 divided by 2, which is a negative 1. So I know that the coordinate of my vertex down here has an x coordinate of negative 1. Then to find the y coordinate, so this is in the format of a coordinate. This is your x value. This is your y value. To get the y value, we take f of negative b over 2a. What does that mean? We take our value that we just found for x, which is negative 1, and substitute it into the function to find y. So I get negative 1 squared plus 2 times negative 1 minus 3 that gives me 1 minus 2 minus 3, which equals negative 4. So the coordinates of my vertex are at negative 1, negative 4. And if you take a look at the graph, the coordinates of my vertex are negative 1, negative 4. Okay, so that's a new idea. How do you find the vertex? You use an algebraic formula, x equals negative b over 2a. Once you find x, substitute it back in the function to get the y value of your vertex. All right, next is finding the y-intercept. When we graph lines, the way that we found the y-intercept is we let x equal 0. So in my function, I'm going to let x equal 0. So I want f of 0 equals 0 squared plus 2 times 0 minus 3. The first two terms cancel out and become 0. F of 0 equals negative 3. So another point on my graph is the y-intercept when x is 0, y is negative 3. And you can see the y-intercept here. We found it algebraically. It's 0, negative 3. All right, and in some cases that's enough. Once you know the y-intercept, from here we counted to the right one, up 1. If I count to the left one, up 1, I automatically can graph that point. Okay? Sometimes you'll be asked to find the x-intercepts. X-intercept is you let f of x, y equals 0, and solve for x. So in this case, I would have x squared plus 2x minus 3 and set that equal to 0. So this should look really familiar because we just spent a couple of sections how to solve quadratics. So when you had a quadratic equation set equal to 0, what that represents on a graph is if the quadratic function, it represents the x-intercepts. Okay? So this is factorable. So I'm going to factor x in the first spot, two numbers multiplied that give me negative 3, but added that give me positive 2. So that's going to be minus 1 plus 3. I get two solutions, x equals 1. Take x plus 3 and set it equal to 0, subtract 3. So my two x-intercepts are 1, 0 and negative 3, 0. And those are also on the graph. So there's my 1, 0 and negative 3, 0. So that gives me two more points. So you can find the vertex, the y-intercept. Once you have the y-intercept, you have its reflective point because it's symmetric. And then if your graph does cross the x-axis, then you can also find the x-intercepts. Okay? So remember when we talked about solving quadratics? In this case, I had two answers. So just a note, okay, on x-intercepts. You could have two x-intercepts, just like we had above there, if our graph touches in two places. Okay, two x-intercepts. Or you can have one x-intercept. Remember, it happened sometimes that we ended up with the same answer twice? If that's the case, then that means the vertex touches right at the x-axis. That's when you have one x-intercept. Or it's possible to have zero x-intercepts. If your graph doesn't touch the x-axis at all, since it has a point, a minimum or a maximum in a turning point, this graph doesn't touch the x-axis at all, so it would have no x-intercepts. It would have no real solutions. It would be the square root of a negative number. Okay, so that's what can possibly happen when you're finding x-intercepts, and how that's related to solving quadratic equations. Okay. So next example comes from homework. It says sketch a graph of the given parabola by using only the vertex and the y-intercept. So we don't need the x-intercepts for this one. We do need the vertex. The vertex, to get the x-coordinate, we use the formula negative b over 2a. And we check and see, is our equation in the right format? Yep, we're okay. It's got the x squared term, the x term, and a constant. In this case, a is equal to 1, b is equal to 4. So the x-coordinate of our vertex is going to be negative b, negative 4, over 2 times a. Negative 4 divided by 2 is negative 2. So that's the x-coordinate of our vertex. To get the y-coordinate, take your answer for x and substitute it in the equation. So y equals negative 2 squared plus 4 times negative 2 minus 5. Negative 2 squared, remember to put parentheses around when you substitute negatives. Negative times a negative is a positive 4, minus 8 minus 5, and we end up with a y-coordinate of, let's see, negative 9. So negative 2, negative 9 is our vertex. So negative 2, negative 9 is our vertex. Now, I know that my graph is going to open up because this x squared term is positive. So the next thing I need is the y-intercept. So I'm going to let x equal 0. That gives me y equals 0 squared plus 4 times 0 minus 5. So that ends up being y equals negative 5. So I know another point on my parabola is 0, negative 5. And now I know, since by symmetry I can get that same point on the other side, but all we needed was the y-coordinate and the vertex and the y-intercept, and now you can sketch. Oops, my math lab, you'll have a much easier time with the graphing tool in my math lab. There we go. All right, so that's graphing using the y-intercept and the vertex. So you try the next one. Notice we've got y equals x squared minus 64. And we'll find the vertex, the y, and the x-intercepts this time. Notice in this case, a equals 1, there is no x term, so b is 0, and c is negative 64. So when you take negative b over 2a, you get negative 0 over 2 times 1, which is 0. Now, that's the x-coordinate. To get the y-coordinate, substitute 0 in for x, and we end up with negative 64. So the vertex is at 0, negative 64. There's the vertex. I know my graph is going to open up again because that's a positive. Okay. So next, y-intercept and x-intercepts. So for the y-intercept, let x equal 0. And I get y equals 0 squared minus 64. So I get exactly the same point. So 0, negative 64 is not only the vertex, it's also the y-intercept. So I don't have another point to be able to figure out how wide my parabola is. So that's why we also have to find the x-intercepts. For the x-intercepts, we're going to let y equal 0. So we get x squared minus 64 is equal to 0. If you recognize that's a difference of squares, that factors into x plus 8, x minus 8. Set each factor equal to 0 and solve. I get x equals negative 8 and x equals 8. So my x-intercepts are 8, 0 and negative 8, 0. Now I've got a couple of more points. There's 8, 0, negative 8, 0. So you can use the graphing tool to create your parabola. So it should go through those 2 points. All right, next example, where do we use the quadratics? Okay, so one of the real life examples is something of this form. The height in feet of a fireworks shell shot vertically upward as a function of time in seconds is h of t equals negative 16t squared plus 96t plus 3. How long should the fuse last so the shell explodes at the top of its trajectory? So think about the height of a fireworks shell shot vertically upward. So physically, it goes up and then it comes down, right? So what this is going to look like, over time, when you shoot something in the air, over time t, if you shoot something up in the air, it's going to go up over time, and then it's going to drop back down and then hit the ground at some point. So this is basically the trajectory shape. When you shoot something in the air, there's a maximum height somewhere. And the relationship that we're looking at is the vertical axis this time is height. And for us, this one is measured in feet for this problem. And the horizontal axis is time. And for us, this is measured in seconds. So over time, when you shoot a firework in the air, it goes up and it comes down. So what the question is asking is how long should the fuse last so the shell explodes at the top of its trajectory? So what it's really asking is, at the top of the trajectory at maximum height, what is the time? So we're looking for the x value on how long it takes to get to the top. So the maximum height is the vertex. So what we're really looking for is the vertex of this particular parabola. Okay. And the vertex, in this case, it's the t, time in seconds. So let me get my variables right. Time is equal to negative b over 2a is how long it takes to get to the maximum. So in this case, we're written in the right order. A is equal to negative 16, B is equal to 96, and C is equal to 3. We don't need C at this time, but we do need A and B. So T equals negative 96 divided by negative B over 2A, 2 times negative 16. So we want negative 96 divided by negative 32. And we end up with 3. So it's going to be 3 seconds. So it's going to take 3 seconds for the firework to go from here to the top of its trajectory. Okay. If we wanted to know what the maximum height is, we would substitute 3 back in our equation. H of 3 would tell you maximum height. And if we wanted to know how long does it take for the firework to hit the ground, then we would be looking for an x-intercept.